I am ready to start now, and I am very happy to be here. My name is Mats. I normally work in Göteborg on the west side, and have come here to Stockholm today to meet with all you guys. I have a background from here, and it's really good to see so many here. I'm engineer, and I head what's called the data factory within AI Sweden. I love to compete. And that's why I'm at AI Sweden. We really enjoy that. And back to your point here from earlier this morning, collaboration is what it is about, playing a team. Sweden is a unique place. I hear sometimes that people say Sweden is a small country. It is not. Sweden is a superpower. And that's how we have to think of ourselves. This is the place where we get stuff done. I know of no other country that has this broad set of industry. We have everything from aircraft to cars to telecom to automation companies like ABB. We have then through the process automation, mines, consumer products, Klarna, so forth. No other country have that in one place. And we are about leveraging that at AI Sweden to learn from each other, because there's a lot of AI going on in all these different countries, and putting it together in one place and then sharing it with everybody else is sort of the secret sauce that we are applying. So our mission is to accelerate the application of AI in Sweden, both academic, in public sector, and in industry. And we do that by investing together and sharing with many. So our partners come in with the mindset of putting their best engineers in place, putting their equipment in place, and learning how it's used, and then bringing that home. And it's speed. It's a speed game. We have about 107 or 110 partners today. And to have speed, what we don't do, we don't sign any NDAs, we don't sign any IP agreement, and we don't sign any special agreement. So by cutting all that out, we can get anything started really fast. It's a little bit unusual for many companies, but some of the world's biggest tech companies are now members and are all in for this, because they understand that we want to compete on speed. And trying to get IP or patents on AI today, by the time they issue, it's already too late. So it's much better to get in and get the know-how than to worry about negotiating agreements. So that's part of the secret sauce. I'm going to talk about today a case study, and I have with me a colleague here, Agneta, who's also somebody you can ask about how AI Sweden works in the breaks, if you don't see me around. And what I'm talking about today is a case study, and this is to illustrate how we think about stuff at AI Sweden. And this is challenges I like, how you have your cake and eat it. So we try to do things that are different and that are useful. When we set up AI Sweden, see if it works. Yeah, one of the first things we did, this was in 2017, was to figure out a way to have a national AI resource that's faster than what we saw in other countries. And what you can see here is we created both a data factory here to deal with all the data challenges and infrastructure at the same time as we had what we would call an AI research center, or we call it an arena, because Sweden is really an arena, and we have presence in many locations in Stockholm, in Linköping, in Luleå, in Örebro, in Göteborg, in Lund, and many places. So it's really like an arena where we can get together and interact. So by having both the algorithm researchers and the data factory in one place, we can leverage from each other, we can learn. So when the algorithm people, the model people want certain data in certain ways, and we talk to the data people, the people who build the infrastructures and others, and they can tweak that, and then they can learn from each other. It's very similar to what you talked about at CERN, where you have the physicists working with the engineers. The physicists want a certain angle on the protons or certain energy, and then the engineers have to figure out how to build it and tell the physicists, well, you can't do that. And then they talk to each other and they figure out how to do it. And that's sort of what we do here. And that is the key to running faster than what we see in other. And it worked. We thought of this in 2017, and the amazing thing, it has worked. So what I'm talking about now is really what these two guys are talking about here. And that is two former ministers from the previous US administration who say that competition for global influence in the 21st century requires protecting and harnessing data to achieve commercial, technological, and military advantages. And so far, China is winning and the West is barely even engaged. So being a competitive person, I thought, well, that's a good competition to go for, and what better place to be than here. So we took that on, and within our data factory, as we tried to determine what we should do, we made a model that looks like this, where we first said that we should invest, or we should put together equipment infrastructures and things that complement other resources that are already in place in Sweden. So, for example, the Wallenberg Foundation has donated a superpod to Linköping University. It's fantastic donation. It's a huge machine. It's really good for Sweden. So let's not buy another one of them, because we already have one. So what else can we do that is not more of the same? So we started looking for that. And we decided that whatever we do in line with the previous picture here of both the data factory and the arena, we should do something that's useful both to people who train models, but also for people and companies who build this kind of infrastructure. Then we get together. So we have, for example, automotive getting together with infrastructure manufacturers, and infrastructure manufacturers are companies like HPE, like Intel, like Dell and others. They get together at AI Sweden, they figure something out, how to build things, how to use it. And then once they figured it out, built a prototype or something, then they go into the commercial system. And here's where they start writing the commercial agreements and write all this kind of procurement and so forth. But here, what we see is that people just donate it. And I really learned that another trick to speed is to have no money. If you have no money, it goes really fast. Surprising, but it's true. So the trick there is that if you want money, you first have to apply for it. You have to have it approved. You get the money. You have to do a procurement process. Somebody wins the procurement. Somebody else complains about it. You eventually get the stuff, and then you have to set it up. If you don't have any money, you eliminate that too. So then you tell your partners that in order to have your equipment here, you have to give it to us. And if you give it to us, we can match that with public funding. And so when we built one part here, which I'll show you later, from the time we said we're going to build it till we had the first equipment was 3 weeks. And today we have equipment completely donated to us in this lab that has a value of about 70 million SEK. So it works. So this is how you have and eat your cake. What we can do now, and what is the business case? So you all look surprised, but there is a business case, and I do have a business background. I'm not academic. Well, I'm academic too, but my background is that I headed in Emerson Electric, which is a big company like Siemens and so forth. I was head of R&D for Emerson in Europe before, so I reasonably well understand US companies. I can play their game, but here. So what the business case is that you help them build market. So by putting their equipment here, they help companies in Sweden innovate, reduce their risks, reduce barrier to investment. And that way, you accelerate the AI development to this border where we can do things at us. And then they can go out and do procurement. So what we do is we inflate this blue AI ecosystem, the market, much faster than would be done otherwise. And that is the business case. So let's see. A fundamental important thing to understand when you go in AI is that the quality of your AI model is the training. So the way you train, the quality of your data, the amount of data, how many times you train it, and so forth, really impacts the quality of your AI model. And this is traditionally how we do it, and I am normally head of research at Zenseact, which is the company within the Volvo Cars group that develop all the AI solutions for autonomous cars. But I'm on leave from there now because this is well, I shouldn't say way cooler, that would be bad to say, but this is about as cool and has a lot of advantages for the automotive industry as well. So this is how we do it, and this is how many companies do it. You have a sensing unit of some sort. In this case, for the automotive, we have a car. A car like this collects at least 4 gigabits of data per second. If you drive for an hour, you have a lot of data. Then all of that data you can't annotate, so you down select some, annotate that, and then you put it into a huge machine, something like the Berzelius. A machine like that can cost you 500 million kronor. And then you get your models. And as we said, the quality depends on the data volume and the quality of the data. And we create huge amounts of data. So the problems with this traditional way of doing it is that we have privacy concerns when we drive around in public collecting data. We have compliance issues, not only with GDPR, but also there is fotoförbud or no photography zones. There is China, for example, don't allow you to bring data out and so forth. So there's a whole bunch of compliance concerns that can be raised. It costs a lot of money. It takes a lot of time to transfer all this data. You can just imagine how long it would take to get the data out of the car on a wire. So we have to take the hard disk and lift it out and plug it in. So we don't think that this current direction is sustainable. We can't just keep adding more and more data and build bigger and bigger. And especially now, in the current geopolitical situation, we expect that the regulations around data transfer and data collection in public is going to tighten up significantly, really fast, really soon. So it is not sustainable. And what we want, well, this is again, have and eat your cake. You want more data and you want less data. You want to share this data, but you have to keep it private. You want to transfer the data, but you have to keep it local. And there is no lagom here. For those of you who don't understand, lagom is sort of a bad compromise. It's kind of lukewarm, right? So we can't compromise. You need both. And the question is how? And for me, this is a really cool challenge. And this is the kind of stuff we go at AI Sweden. It's like try to turn it over and go at it from a different angle. Don't try to improve 5 or 10%. Take a different way. So we reformulated the questions because these problems really depend on the way we trained in the past. So we said, well, what if we can do this? What if you say that the data is born on the edge, in the cars, in your cell phones, or wherever? And why don't we keep it there? That eliminates a lot of problem. And when we say we want to collect the data, isn't really the knowledge we're after, the model parameters that we want. And if you formulate the problems that way, you get into something called edge learning, federated learning, swarm learning, decentralized learning, and so forth. The first paper on this came by Google in 2016, where they made a principal paper, simulated it, and it was quite cool. And we thought, well, that's interesting. The way it works is that you create an algorithm, an empty algorithm. You transfer it to your devices, edge devices, cell phones, can be hospitals. Hospitals can't share data, so hospitals is a big area of application. I illustrated here on cars, but it's really any data generating thing. You let them train in each car, and you get a really bad model in each car because it only has a small amount of data. But what you do then is you transfer the model parameters back to the central location, and there you federate it. And there are many different ways you can do that. The simplest way is to just average it, but there are other ways too. Another approach to do it is swarm learning. You get rid of this central part and you let one of your devices be the federating unit, so you just transfer it to that device. So this is really easy to understand, right? It's not all that complicated to figure this out. Now comes the question, but how do you actually do it? And you know, how does this scale? What are the frameworks that are useful? And all these kind of questions. How do you do annotation in the field and so forth? Where is the ground truth? And a number of our companies, both users and companies who produce the infrastructure, said we'd like to figure this out because this could be potentially a whole new way of doing AI training. So what we offer at AI Sweden is a test bed, and the test bed is normally empty until our partners get together and say, we'd like to do something like this. And then, as I said before, since we don't have any money, we just tell them, fine, give us the stuff and we'll set it up. And so we built this Edge lab. To its first point, it took us 3 months from when they came in and said they want to do it. And now we've sort of expanded on it and put in a lot of extra infrastructure for 1.5 years extra. So now we actually have a very, very good lab. So it really stands on the AI Sweden basis in the data factory, in our test bed. And there can be other labs too coming up here. So this is what it looks like today. And you're welcome to come there. As I said, we have no NDAs and IP agreements. You can just come there and take pictures. Some people have done that. What we have in here is everything from small units, Raspberry Pis, Google Corals, a whole bunch of them. We have different car computers. So these are real sort of field computers that we've gotten from Volvo Cars, from Zenseact, from others. They give to us. We have in here huge capacity, rack-mounted things that are like in hospitals, like in public authorities, donated to us by HPE, by NetApp, by Dell, coming in by Intel. We now have even space computers here that come as the satellite computers, because this is really an interesting application in space too. So the way you should think about us, we don't sell anything. We're not a profit organization. We're a national resource. And the way I try to explain it is like we are a gym. So if you have a membership at AI Sweden, you can come there and work out. And you build your own strength. I can't build your strength. So the more you come to work out, the stronger you get faster. And that's the only way to build your strength, is to go there and work out. And it's really fun to work out with friends, if you will. You can bring your own equipment too, if you want to work out on some of your own equipment. What you can do today, you can test all sorts of different topologies, different compute plans. You can explore all these different questions you might have. And we set it up like a Lego block system, and it's accessible by VPN, so it's possible to connect in externally from within Sweden. It's required you're a partner, otherwise we don't give access. So we have this one-size-fits-all, no negotiation. This is how we do it, and that's how we save time and some overhead costs too. No lawyers. Oh, well, we have lawyers, but we don't have them for negotiations. So some of the visitors, the embassies in Sweden, they have scouting organizations that do a good job. Here are some visitors that have come to us at their own request. So this was Prime Minister of Norway, Prime Minister of Estonia, José Marie Griffiths. She is on the National Security Commission for AI in the US. She came. MIT's been there and are now members. We have a state visit coming up in October. The King and Queen of Netherlands are coming. So it's raising a lot of interest to come here and see how we do these things. Many people want to copy this. And we have, I can say today, a world-class lab. We have a lot, many people say they have world-class, and it's easy to say, but I can actually prove it. That's good. And think about a film studio. And this is what I'm trying to illustrate here. You can have very cool cameras, very cool lighting and so forth, but it doesn't make you to Hollywood. So our challenge now is how we become Hollywood for edge learning. How do you get the best actors, the script writers, and the big thinkers to come to us and develop this technology? There's no better place to do this than here. And we have now formed a global edge learning consortium. Some of the biggest companies in the world, leading academic institutions, are now members here to push this forward, together with Swedish companies, of course. We started up in these three areas: mobility, health, and space, because that is where it's clearly very, very useful to start with, and they were on board already, so we said we'll go where it's fastest. We got cybersecurity in as well. So the US commissioner who was here, she runs within the university she's president of. They have a very big cybersecurity lab. And she said, well, we don't have a lab like yours. Can we join? And so they do the research for us now within cybersecurity for edge learning. So we have that from start. And here you can see some of the students. We set it up again really fast. So she suggested this in February. In this summer, we had 5 students and 2 professors. First 4 weeks in Sweden, then 4 weeks in the US, just to get going. And we try to get it going like really fast. If it's a good idea, well, let's just do it. European Space Agency found out about what we were doing. And the day after they found this out and saw the results, they called us up and said, could we designate you guys as a phi lab? And that's a leading lab in Europe to push technology for AI in space. And so we were designated as the first phi lab. And what we do here, and you can understand the idea, is that by not having to transfer data from satellites to Earth, you save a lot of bandwidth for the training. You train in the satellites, you federate, and then you have your models. So this is, from the European Space Agency point of view, a very strategic technology, and they wanted Europe to take that lead, so they said, take it and run with it. So we are doing that now, which is very helpful. And we got 2 scientists from European Space Agency here in Stockholm now, who are sent up from ESA to work with us and push this forward. Something that was also surprising in our surprising spree here is that the best university for us in Sweden has to be in the agriculture university. I would not have guessed that, but there are many things I wouldn't have guessed here, I can tell you that. But the agriculture university has been fantastic. We could not be where we are without them. So you might ask why? Well, the answer is quite simple. We were trying to do things with road data in our labs, and because we don't sign all these agreements, you run into GDPR issues like that. And the question is, how do we have the cake and eat it? And it turned out that agriculture university had fantastic data, seabirds. And seabirds could be used instead of road data. We had no idea, but it works. So we have now trained our automotive models on seabirds to prove what can be done. And then once we know what can be done, we take them back inside the automotive companies and train on our own data, of course. So we can't drive on seabirds, but you can test your entire infrastructure on that. And when it comes to hospitals, instead of going through ethics, and all these other reviews, we can train on pig lungs and cow hearts and stuff like that. So you don't have to have patient data just to set up the infrastructure. Save a ton of time. So on space, we're getting a lot of companies coming in, and one way to get going fast is to do it through proof of concepts. And we do encourage our members to bring their data sets in, and we'll host hackathons. And it's out of these hackathons that many of these things have come. People think about it very differently. And then we say, okay, let's try it. And 4 out of 5 has really worked out at a big scale. And we see other labs coming up now. We have a foundation model lab or a natural language lab being set up in the same way here. More gray here, perhaps an energy lab coming up. There's some discussion on that as well. So, and following the same model, speed, just put the stuff in there. We're not going to pay anything. If you want to do it, just bring it to the gym and just work out. And with that, I want to have my last slide, which is if you want to see more what's going on, we formed this platform called My AI. It's myai.se, and you can sign up for a free account there. There are all sort of use cases and there are events and things like that going on. So it's a new social network for people in this field. So with that, I'll pass it on to next speaker.